Okay, in this video, I will be going through the must-do and the kinematics and kind of walking you through. So if you have struggled a little bit on doing some of these, you can watch and hopefully have a better idea on how to actually do the problems. So we're going to start off with this distance and displacement worksheet. And the number one thing here is that anytime you want to do these problems, you always want to start with a picture. And you're going to hear me say that a lot in going through a lot of these. So if we look, a man starts, and we'll just put a little red X where he starts, and he's going to go 25 meters south. So I'll switch this in orange. So 25 meters. And then it goes and turns 100 meters west. Now what I'm doing here is I'm actually creating a vector diagram. And I'm adding these vectors head to tail. I mean, this would be the path he would normally take anyways. He's going to go 150 north. And then 25 west. Oops, should be a little longer, my fault. 25. And then 25 more north. And then finally 125 east. So I draw that picture out. He's going to end right about here. Oops, I need to move my face. There we go. Going to end up right about here. This is where he ends. And I'll put that as a little red X as well. So if I want to find out the distance is literally just going to be adding it all up. And so if I go 25 plus 100 plus 150 plus 25 plus 25 plus 125, I'm going to end up with 450 as being his distance. So the distance travel is 450 meters. And the difference between distance we're going just how many steps he took or how many meters he went, that kind of thing. Whereas displacement, we want to know how far is he from where he started to where he ends. So this right here would be the displacement. And what I can do here is I can say, all right, well, I know that I ended up going 100 east, 100 west, 25 west, and then 125, I forgot to label that, east. Well, if I add up both of those together, I end up with 0 east-west. So my only displacement is going to end up being north-south. So if I look, I went 25 south, 150 north, and then 25 north. The 25s cancel out. So my displacement ends up being, and I'll leave this in green, my displacement is going to be 150 meters. And with displacement, I also have to have a direction. So 150 meters north. Okay. All right, looking at the next one, race car drivers are on an oval track. Each lap is 2 miles long. If crossing the finish line, a 500-mile race. What's race car's displacement? Distance? Well, distance, they kind of give it to you, so it's kind of a trick question. It's a 500-mile race, so the distance is 500 miles. Whereas the displacement is from the difference between where he started and where he stopped. Since it's an oval track, he's going to go around and around and around and around, 100 or 250 times, but he's going to start and stop in the exact same spot. So his displacement is going to be 0 meters. If we look down at number 3, it says what's the difference? Difference between distance and displacement. We've kind of mentioned that before. Distance is just how far you've gone. We don't care what direction or anything like that. Displacement, on the other hand, is your change position from where you started to where you ended. And with displacement, you need a direction. Okay, so calculating distance, add it all up. Displacement, you're just going to add them up. So we've got 150 north, 30 east, 75 south, 75 east, 75 south. So basically the north-south is once again nothing. And if I add up from start to finish, so over here, here's my displacement. This is going to end up being 105 meters. And I've got to have the direction there. But this arrowhead will suffice. As long as I have the arrowhead, that shows me that I went east. Okay, jumping into the next one, speed and velocity. Sorry about that. Julie can run a 100-yard dash in 45 seconds. What's her speed in yards per second? Now remember, we've talked about the guess method. And with the guess method, you always want to write down your givens first. So if I write down, all right, Julie can run a 100-yard dash, so the distance she's going to travel is 100 yards. The time is going to equal 45 seconds. So what's our speed? Now, in our guess method, we write down our givens. We write down what we're looking for, our unknown. Then we have to go find an equation. Conveniently, there's an equation. V average is equal to D over T. And since we want our speed, we're going to use our distance divided by the time. So we go 100 yards and divide that by 45 seconds. And you end up getting like 2.22 yards per second. Now, normally in here, we will always live in meters. You heard me say this before in Unit 1. We like to live in an MKS world. But for this, as long as our units are consistent, did 100 yards divided by 45 seconds, so our units will be yards per second. Okay. In number 2, we're going to take that information, that 2.2 yards per second, because now it's same Julie. So her velocity is still going to be 2.22 yards per second. And now she's going to go a 5-mile run. Distance is 5 miles. And I'm looking for the amount of time. Now immediately here I'm going, uh-oh, there's a problem. Because my velocity, and I'll highlight this, has yards per second, and my distance is in miles. In order to do this, I have to have consistent units. So what I need to do is that I'm going to have to change from miles into yards. And this is that unit conversion, that dimensional analysis that we talked about before back in Chapter 1. We know that 1 mile is 1,760 yards. So remember the rules. We multiply by what we want. So we want yards. So carry the number through, 1760. We divide by what we have, miles. Okay, and we carry the number through, that's 1. So I end up getting the 5 miles times 1760, which I believe is, 8,800 yards. Once I have that, I have consistent units. Now I can go back and use my equation. My equation I want is still V average is equal to D over T. But now I know my V. My V is going to be 2.22 yards per second. My D is 8,800 yards, and I'm looking for the amount of time. From here, I'm going to cross multiply, and I'm going to write that out this time. Next time I won't. But cross multiply, I get 2.22 times T is equal to 8,800 yards. Okay. Now notice on the second time around, I didn't write in the units. Okay, I don't have to. But so now the next thing I want to do is divide each side by 2.22. And so that's going to give us about 3,963. Okay. And again, if you use 2.22222 repeating, your time is going to end up being 3,960 seconds. So depending on where you rounded, you may get a slightly different answer, but that's okay. If we look at the next one, you're driving your car at a speed of 45 miles per hour. If you drive your car for 5 hours, how far have you traveled? Again, using my guess method, my speed, my V, is equal to 45 miles per hour. And you notice I changed that up. Instead of doing MPH, I wrote miles and divided by hours. Doesn't matter, but I want to know that that's miles divided by hours. And then my time is going to be 5 hours. And I'm looking for the distance. How far did I travel? So doing my equation, V average is equal to D over T. Because again, I have V, I have T, I'm looking for D. Plug in my stuff. So I have 45 miles per hour is equal to my distance over 5 hours. So 45 times 5, that gives me 225. So my distance traveled, 225 miles. Now, if I'm driving the same car at the same speed as the previous problem, how far will I travel in 15 minutes? So again, I can do the same thing, same speed. So I still have the 45 miles per hour, and my time here is going to be 15 minutes. Okay, at this point in time, I got to go, uh-oh, something's wrong, because I don't have consistent units. I have hours and I have minutes. I have to have consistent units in order to do these problems. So what I'm going to do is I'm going to change from my minutes into hours. I could go by 45 miles per hour and change that into miles per minute. It would work out the exact same. But for me, it's more intuitive to change minutes into hours. So I'm going to multiply. I remember that there are 60 minutes. I'll write this here in 1 hour. And so I'm going to multiply by what I want. I want hours. So 1H. Divide by what I have. I have minutes. Carry the number through. So it's going to be 15 minutes times 1 hour divided by 60 minutes. And that's going to give me 0.25 hours. So now I can plug into my equation. V average is equal to D over T. My V average is 45 miles per hour. My distance is what I'm looking for. My time, that's that 0.25 hours. And so 45 times 0.25 is going to give me a distance of 11.25 miles. Okay, continuing on, the same sheet. Ellen has a top speed of 4 meters per second. How far will she travel in 25 seconds? So again, using my guess method, my average velocity, 4 meters per second. My time, 25 seconds. I'm looking for distance, question mark. So V average is equal to D over T. Plug that in, I've got 4 meters per second is equal to the distance over 25 seconds. Cross multiply, my distance kicks out to be 100 meters. Now we have Ellen slowing down to a speed of 2 meters per second. How long do we move a distance of 30 meters? So my V average now changes from 4 to 2 meters per second. My distance is 30 meters, and I'm looking for my time. That's my question mark. So now, same equation, V average is D over T. So now it's 2 meters per second is equal to 30 meters over T. Cross multiply this. T is going to end up becoming 15 seconds. Okay. Number 7 is a straight unit conversion. So we can move a total distance of 5 kilometers in 1 hour. What's your speed in kilometers per hour and in meters per second? Well, if you have your distance of 5 kilometers and you have a time of 1 hour, then your speed in kilometers per hour, well, V is equal to D over T. 5 kilometers divided by 1 hour. Yep, just that easy. 5 kilometers per hour. Okay. Now, the next one is a unit conversion one. We have to change into meters per second. So what I'm going to do is I'm going to set up my 2 ratios, or set up my 2 equalizations. So I know that in 1 kilometer, write that out, there's 1,000 meters. Now, if you're not sure, the other way you could do this, and I'll put this in orange, you could have also written this 1 times 10 to the 3rd meters. Because going off our reference, it was the kilo stands for times 10 to the 3rd. The next one, and if you don't know this, that's okay. I can explain how I got it. But I know that in 1 hour, there are 3,600 seconds. Now, if you're not sure how I got that, basically what I did was I said, hey, I know that in 1 hour, there's 60 minutes. And then in 1 minute, there's 60 seconds. So 60 times 60 gave me the 3,600. So from here, I'm going to do my unit conversion. I'll put this in blue. So I'm going to multiply by what I want. Okay, so I want meters. So I'm going to go meters, drag my number with, so 1,000 meters, divide by what I have. Oh, kilometers. Okay, that is good. The life is good there. So my kilometers are going to kick out. Then I'm also going to multiply. Now this is where it gets a little weird because it's not really multiplying by what I want. I have to divide because the hours is on the bottom. I'm going to have to go put 1 hour on top and 3,600 on the bottom. And here's the reason why. Eventually, I have to cross out the hours. And since my hours is on the bottom down here, my hours has to be on the top up here. So that's a little bit weirder than what we're used to. But we could have also just changed hours into seconds from the first time and done it the exact same way too. So I've got 1,000 divided by 3,600 times my 5. And that's going to give me, hang on, I got it in fraction form, 1.39 meters per second. All right, number 8 is a relative velocity one. Mrs. Cyber is chasing down students in the hall. She has a top speed of 5 meters per second, and Matt has a top speed of 2 meters per second. Okay, so what's going to happen? If you think about this, Mrs. Seibert is here, and we'll put her as running. You get the idea? And she's going along at 5 meters per second. Matt, significantly slower, possibly because of his broken leg that I just drew. Sorry about that, Matt. Is a top speed of only 2 meters per second. Okay? So if you think about this, relative velocity-wise, Seibert's moving at 5, Matt's moving at 2. That means Seibert is actually gaining on Matt only at 3 meters per second. The other way to think about this too is after 1 second, Seibert will have traveled 5 meters. Matt will have only traveled 2 meters. So Seibert is gaining on Matt 3 meters in that time period. She's going to gain 3 meters every second. And so the relative velocity, I'll just put this as a VREL, for relative velocity, is going to be 3 meters per second. That's the relative speed between the two. And the distance is 6 meters, and I can solve for time. So on this one, 3 meters per second in, I can use my equation. V average is equal to d over t. And so we've got my 3 meters per second is equal to 6 meters over t. So t is going to end up becoming 2 seconds after I cross multiply. And I'm going to stop there for the end of the first one.